Let's take a look at this example. Again, we're supposed to prove the identity. Like always, we can start from either side, from left one or right one. This time I'm going to start from right side. Copy down this side. We have sine 3 alpha is equal. I can rewrite this expression as the sine of the sum of two angles. And I have sine, open parenthesis, alpha plus 2 alpha. Now, this is the sine of the sum of two angles. In order to simplify this a little bit, I'm going to use the formula for the sine of the sum of two angles. And rewrite this as sine alpha times cosine 2 alpha plus cosine alpha times sine 2 alpha. Now we have cosine of the double angle and I have sine of the double angle. I'm going to use the formulas for the double angles in order to simplify this further. So I have sine alpha, and instead of cosine 2 alpha, I'm going to write cosine square alpha minus sine square alpha plus cosine alpha, and instead of sine 2 alpha, I'm going to write 2 sine alpha cosine alpha. Next, I'm going to simply multiply this sine by every single term inside of the parenthesis and this cosine by every single term inside of that parenthesis. So I'm going to have sine alpha times cosine square alpha minus sine cube alpha plus 2 sine alpha cosine square alpha. Next, you're supposed to look at the original problem, especially at the left side. We do not have any cosines over here, right? So means we have to eliminate cosine from this expression. So what I'm going to use? I'm going to use the Pythagorean relation, which says sine square theta plus cosine square theta is equal 1. Okay, so I'm going to simply write sine alpha, and instead of cosine square theta, one more time, we do not have cosines in the original equation, that's why we have to eliminate these cosines. I'm going to write 1 minus sine square alpha. Let me remind you, I use the Pythagorean relation. If you want to solve this relation for cosine, you're supposed to move the sine to the right side, and you are going to have cosine square theta is equal 1 minus sine square the given angle. In this case was theta, but in our case is alpha. Next, copy down minus sine cube alpha plus 2 sine alpha, and instead of cosine square alpha, write 1 minus sine square alpha. Next, perform the multiplication, and we have sine alpha times 1, and I have sine alpha times negative sine square alpha. This is sine alpha minus sine cube alpha. minus sine cube alpha. I just copy this one down. And I have over here plus 2 sine alpha times 1 is 2 sine alpha. And I have 2 sine alpha times negative sine square alpha is equal negative 2 sine cube alpha. Next, we're supposed to combine the like terms, and we have minus sine cube alpha, and I have minus sine cube alpha, and I have minus 2 sine cube alpha. So this is going to give me minus 4 sine cube alpha, and I have sine alpha and plus 2 sine alpha. This is 3 sine alpha. So I have 3 sine alpha minus 4 sine cube alpha. Let's take a look what we have got. Compare this expression with the left side. Okay, so we can say that the left side of my identity is equal to the right side.